Hi, everybody. So this is my Unit 3 summary. And this unit is really about kind of one really big thing, which is how do people make decisions? Um, Certainly in an economic sense, how will a person come to a decision? So what we're going to do is go through the two elements of the decision, one of which is going to be kind of talking about people's preferences and their marginal rate of substitution. And the second part, which is people's sort of constraint, right? So we're going to talk about the feasible frontier, or sometimes the budget constraint. And that tells us about what people are constrained by. And we'll look at their marginal rate of transformation. And what we'll see is that a person is optimizing, they are maximizing their utility when they choose an allocation, which means choose quantities that give them a place where their marginal rate of substitution is equal to their marginal rate of transformation. So where I want to start, though, is actually by talking about a couple of concepts, so marginal and average product. So our context here is we're thinking about someone who is studying for an exam, and we're seeing different amounts of hours they could study and how that will translate into their final grade. And so what this purple curve represents is a production function, right? Where the hours of study is their input and their output is their final grade. And we could look at their average product. And to do that, we would pick, say, a particular point on the curve. So say we could pick maybe this point. And we can see, so if the person puts in 4 hours of study, they'll get a final grade of 50. And so we could work out their average product by doing 50 divided by 4. And then we could maybe choose a different point, maybe up here. And so here we can see that they've put in 10 hours of study and they're getting an output, a grade of 81. And so we could work out the average product by doing 81 divided by 10. And what we can actually see here is that the shape of this curve, the fact that it's sort of concave and then in fact levels off, shows us that the average product is getting lower and lower and lower as we put in, or as the person puts in more hours of study. And these blue kind of dashed lines are showing us actually the sort of the slope that would give us the average product. And you can see as we move to the right, those slopes are getting shallower. Now, a second concept we might be interested in, or quantity, is the marginal product. So what that means is, in this particular case, how much higher a grade am I going to get? What am I going to add to my grade by doing one more hour of study? And the marginal product we can think of not as the slope of these sort of blue dashed lines, but as the slope of a tangent at a particular point. So for example, if we wanted to think about the marginal product at 4 hours of study, we think what we're interested in is, well, how much could I add to my grade if I went from 4 to 5 hours of study? And I could figure that out by actually drawing a tangent at the point 4 and then find the slope of the tangent. But actually, the data down here is an easier way to get it. So if I go from 4 to 5, my grade goes from 50 to 57. So the added output is 7. So the marginal product at 4 hours of study is 7. And we could do this similar thing at, say, 10 and 11. So again, at 10, what I could do is draw a tangent at the slope. And notice if I did that, the tangent here would actually be shallower than the tangent here, which is showing us that actually the marginal product is lower, higher up here. Or the other way, use the data. If I'm at 10, I get 81. If I do 11 hours of study, I get 84. So the extra hour now only gives me 3 extra points on my grade. So a smaller marginal product. So those are marginal and average product. And what we're going to see in a little bit is how we're going to convert this production function into a feasible frontier. But the thing I want to move to next is thinking about a person's preferences, because for a person to make a choice, we need to know kind of what they like. How do they rate different, say, combinations of inputs, different combinations of goods? And in this case, we're going to think along the same lines where we've got this person who's studying and they're studying for an exam. And what we're going to think about is the two things that this person, Alexi, values. One of them is a final grade. So Alexi values getting a higher grade, wants to get a higher grade, but also Alexi values having free time. And so the kind of way that we think about choices in economics is by constructing indifference curves. Curves which show us combinations of goods, in this case, a combination of a final grade and a numbers of hours of free time that Alexi would have equal levels of utility from, right? So this blue line here represents one indifference curve. And what it shows us is at point A, where Alexi has 15 hours of free time and gets a grade of 84, he would be just as happy. He would have the same level of utility from actually having 16 hours of free time and only getting 75, right? And he would be just as happy actually getting 19 hours of free time and a grade of 54. And every combination of free time and grade along this blue line gives Alexi the same level of utility. Now we can actually go down here to a different indifference curve. And again, every combination along here gives Alexi an equal level of utility. Now, what's different between this blue line and this one is that the level of utility on this blue line would be lower. Now that makes perfect sense, right? Because on this blue line, the combinations are kind of smaller quantities, right? On this one, Alexi gets a grade of 54, but actually like quite a small, maybe 10 hours of free time. Whereas on this one, he gets a grade of 54, but more hours of free time. So higher levels of utility are indifference curves that are further away from the origin, right? So that's what these indifference curves show us. They show us kind of levels of or combinations of constant utility. Now, a second really important thing that we can get from looking at an indifference curve is what's called the marginal rate of substitution. And it's what the person is kind of willing to sacrifice, like of one good to get more of another. So if Alexi were at point A, right, what we want to think about to get the marginal rate of substitution is how much of his grade would he be willing to sacrifice to get one more hour of free time? And we can see that to go from 15 hours of free time to 16 hours of free time, he'd be willing to actually reduce his grade from 84 to 75, to go down by 9 points. So that would be the marginal rate of substitution at point A. And like before, when we were thinking about marginal product, what we could actually do is we can think about that as the slope of the indifference curve at that particular point. Now, we could also kind of think about the marginal rate of substitution at a different point on this indifference curve, maybe at point H. And so at point H, we think, right, how much is Alexi willing to decrease his grade by to get one more hour of free time? And in this case, we see to get one more hour of free time, to go from 19 to 20, he'd be willing now to only drop 4 points, right? And again, we could kind of think about the marginal rate of substitution by thinking about drawing a tangent at point H and finding the slope of it. And actually, an interesting thing you can see here is that the slope at point H is slightly shallower than the slope at point A. And what that's telling us is that when we're further over to the right, when Alexi already has a lot of free time, he's less willing to sacrifice his grade to get more free time. So here, when he had 15 hours of free time and you offered him one more to get 16, he'd be willing to drop 9 points. But here, when he's higher up, when he's got 19 hours of free time, if you offer him one more, he's actually only willing to drop 4 points. And so what that shows us is the marginal rate of substitution on an indifference curve is actually changing. And you can see it's actually kind of decreasing as we move to the right. Now, another important thing about marginal rates of substitution is they're not only different at different points on a single indifference curve, they're actually different at kind of the same level on different indifference curves. So what do I mean by that? Well, okay, so if we kind of insist on we're at 15 hours of free time, and then we think about the marginal rate of substitution for this indifference curve versus this one versus the one above, you can actually see that we'll have different marginal rates of substitution. Right down here, where Alexei has quite a low grade, right? If you kind of said to Alexei here, well, what would you be willing to decrease your grade by to go from 15 to 16? You can actually see it wouldn't be very much, right? The slope here is actually like, oh, really bad. The slope here is actually quite shallow, right? Wouldn't be willing to sacrifice too much of his grade to get a higher, like 1 more hour of free time. And that's because he's already at quite a low grade. Now we go up to this indifference curve, and you can see here with this one, still got 15 hours of free time, but now he's got a higher grade. And now if you offer him 1 more, then the slope is slightly steeper, right? Because if you offer him 1 more hour of free time now, he'd be willing to sacrifice a bit more of his grade. So this higher indifference curve has a different marginal rate of substitution than this lower one at the same level of free time. And I could go up and we could look at the same thing here, and you can see like really clearly the marginal rate of substitution at 15 hours of free time on this higher indifference curve, much, much steeper, because up here, Alexei's got a much higher grade, so he's much more willing to give up some of that grade to get more free time on this higher indifference curve. So 2 really key things there. The marginal rate of substitution changes along each indifference curve and is actually different at the same, say, level of free time on different indifference curves. Okay, so that is kind of the first key ingredient in decision making in kind of these models, this economic model. We need to know about indifference curves and the marginal rate of substitution. So the second element that we need to know about is what's called a feasible frontier and the marginal rate of transformation. Now, the marginal rate of transformation is really similar to this idea of opportunity cost. And in fact, we can think of it as opportunity cost. And it's where we think about, well, what would I have to sacrifice to kind of like change my choice? And so just one simple example to illustrate the idea of opportunity cost. We can get that by kind of going through this example here. And what I should say is we've got a person who has a choice between going to the theater, and to go to the theater and go to like a concert in this theater, they have to pay $25. And the other choice is to go to a concert in the park, which is free. So to work out the opportunity cost, as an economist, we need to work out the full sort of economic cost of the choice of going to the theater, all right? So we know that to do that, the person is going to have to pay $25 to pay for the ticket. But if they go to the theater, they then don't go to the park concert. And so we need to think about, well, what would be the kind of monetary value of pleasure that the person would get from going to that park concert? And for this person, the person who puts a high value on a theater choice, that opportunity cost would be $15. So the value that they kind of ascribe, that they put to going to the park concert is $15. So if they decide to go to the theater, they have to pay the $25 to get in, and they lose out on the $15 worth of pleasure they would get from going to the park concert. So the total economic cost to them of going to the theater concert is $40. Now, the benefit they will get, the monetary value of the pleasure that they get from going to the theater concert is $50. So we can now use this to work out the economic rent from going to the theater concert for this person. We know that the total benefit they get is 50, and the opportunity cost of going to the concert is 40. So their economic rent is the total benefit minus the economic cost. We can see it's 10. So there's a positive economic rent, which suggests that they should go to the theater concert, right? Because there's a positive economic rent from them making that choice. Now, I'm not going to go through it, but this other example just shows us one slight difference, which is where the second person only gets a monetary benefit of $35 from going to the concert. And so if they decided to go to the concert, they'd actually get a negative economic rent because the economic cost is higher than the benefit they get. And so they'd actually go to the park concert. So, okay, that concept of opportunity cost is going to be very important when we think about the feasible frontier of a person, or the budget constraint of a person, which is not about their preferences, but about what is possible. So we can get this from actually just kind of thinking about the production function of Alexei, because we're still thinking about Alexei and his exam. And all that we've done, all that we've changed now, is instead of looking at how hours of studying lead to final grade, we just change this to hours of free time. And the reason we do that is because Alexei's preferences are all about grade and free time. So now on this same graph, we can plot both what is possible for Alexei and also his preferences. And we'll see why that's going to be really helpful in a second. So, okay, what do I mean by what is possible? Well, if Alexei had 0 hours of free time, meaning he put all 24 hours of his day into studying, he'd get a grade of 90. If Alexei chose 14 hours of free time, so as in 8 hours of study, he would get a grade of 81. So that's all this curve is showing us, right? The possible combinations of free time and final grade. And I stress possible, not kind of preferences, but what is actually possible. And what we can also talk about then is opportunity cost and marginal rate of transformation. And these are sort of the same thing here, because what we mean by those is, given what is possible, what is it going to cost Alexei, say, to get 1 more hour of free time? So if Alexei is at point A, where he's thinking, I'm going to have 13 hours of free time, and that will get me a grade of 84, what would it cost me to get 1 more hour of free time? What would I have to sacrifice? Okay. And we can see if Alexei sacrifices and chooses to wants 1 more hour of free time, he's going to have to sacrifice getting a grade of 84 and instead get a grade of 81. And so the sacrifice, the opportunity cost of getting 1 more hour of free time is a loss of 3 points on his final grade. And what we can think about, just like with the marginal rate of substitution, is we can think of what I just did sort of in numbers. Sorry, that's a bit bad. Is sort of thinking about what is the slope of a tangent at point A. And the slope of the tangent at point A is what gives us the marginal rate of transformation at point A. It's telling us, what does Alexei have to sacrifice at point A in terms of the grade to get 1 more hour of free time? And we can actually see that this marginal rate of transformation will change as we move along the feasible frontier. So if Alexei was at point C, where he's got 19 hours of free time and a grade of, 57, I think it is, then we can think, okay, we could think one way of doing it would be to think about, right, draw a point, let's find the slope of it. And that slope would indicate the marginal rate of transformation. Or we can look at the numbers here and kind of think, right, so if Alexei is at point C, has 19 hours of free time and wants to have 1 more hour, what is he going to have to sacrifice in terms of his grade? He's going to have to sacrifice, not get 57, but get 50 instead, 7 points. And so the marginal rate of transformation here is higher, right? Bigger sacrifice. And we can see that by kind of just comparing the slopes of the tangents that I've drawn, right? Here, it's getting steeper. So Okay, why is marginal rate of substitution and marginal rate of transformation important? Why are they useful? Well, because when we kind of put all this together, we are going to see that the kind of way to optimize, the way to maximize utility is to choose the point where marginal rate of transformation and marginal rate of substitution are the same as each other. And we can see that kind of graphically by looking at this picture here. So remember that these blue lines represent indifference curves, right? And the further the blue curve is away from the origin, the higher the level of utility. Okay, so obviously to maximize utility, Alexei wants to be on the highest possible indifference curve that he can be. But Alexei is constrained, all right? That's why it's called constrained optimization, because the feasible frontier shows us what is possible. Now, Alexei would never choose some combination inside of the feasible frontier, because then he'd just be, it'd be a waste. So he's going to be somewhere along here, and he's going to choose the point along the feasible frontier, which will get him to the highest possible indifference curve. And that's going to be the point where the feasible frontier and the indifference and an indifference curve are kind of a tangent to each other, where they just touch at one particular point, right? So, I mean, if we look at, say, this indifference curve, all right, Alexei can choose like all these points, so from D all the way down to here, but he wouldn't do that because like he can choose point E, which would get him to a higher indifference curve. So point E is obviously the best point to be at. And that is going to be the point where the slope of the feasible frontier, which is given by the marginal rate of transformation, is equal to the slope of the indifference curve, which is given by the marginal rate of substitution. And so if we want to find the allocation, as in the combination of free time and grade, which maximizes Alexei's utility, we can do that by finding where the marginal rate of substitution and the marginal rate of transformation are equal to each other, where they are the same. And this picture shows us why that's the case. Now, there is another way to do this, to find this, which we can use if we actually know an equation for the feasible frontier and an equation for the utility. And so that's what I'm going to run through next. But just before I do that, I'm going to take a quick little pause. Okay, so just picking up. So a second way of kind of finding what's the optimal allocation, the allocation that's going to maximize utility, is actually mathematically. And so here I'm going to switch to a slightly different example. We're no longer thinking about Alexei. So we make our lives a little bit easier by now thinking about a person who can choose between consumption Y and free time T. And this person is going to have a feasible frontier or a budget constraint, which is just a straight line, okay? And the kind of equation of the straight line is going to be given by this. This is the feasible frontier equation or the budget constraint equation. And I'll talk about where this comes from in a second. And then the person is also going to have indifference curves. And the shape of those indifference curves is going to depend on the equation for the utility function. So here we can see that this person's utility depends on T, their free time, and Y, the amount of consumption that they have. And the utility will be given by T cubed times Y squared. So this will lead to a whole set of utility curves, which, for example, will look like this. And okay, we know that graphically we want to choose like this particular point where the feasible frontier is a tangent to the highest possible utility curve, right? So mathematically, how can we actually find that particular point? Well, what we need to do is find the value of T and the value of Y, which means that the marginal rate of substitution is equal to the marginal rate of transformation. So to find the marginal rate of substitution, we think about utility, because that comes from the indifference curves. Now, we know that the marginal rate of substitution is given by a particular equation, which I'm not going to derive. It's given to us in the textbook, and there's a derivation there. So it's going to be the derivative of utility with respect to free time, or I should say the partial derivative of utility with respect to free time, divided by the partial derivative of utility with respect to the amount of consumption. And so if I differentiate this function with respect to t while treating y as a constant, then what I will get is 3t squared times y squared. And if I differentiate the function with respect to y, treating t as a constant, then I will get 2t cubed times y. And a little bit of a simplification will then lead to this being equal to 3y over 2t. So here's an expression for the marginal rate of substitution at any point along any indifference curve. All we need to know is what's the value of y, what's the value of t, like where we are on the particular curve. And then this will spit out what's the marginal rate of substitution. So the marginal rate of transformation, this comes from what is actually possible. And for this, we need to look at the equation of our feasible frontier or of our budget constraint. And in this case, where does this come from? Well, the left-hand side, the P times Y. So that represents P, the price of consumption, times Y, the amount of consumption. So this left-hand side represents the total spending that the person's going to do, their total expenditure. And the right-hand side represents their total income, because it's the wage multiplied by, so 24 minus T. T, remember, is free time per day. 24 minus T is the amount of hours worked per day. So the wage per hour times the number of hours worked, this is their total income every day. So this kind of has to be true, right? Their total spending has to be equal to their total income. So what we need to do is a couple of things. And well, first thing we need to know is, well, we can't get any further without knowing the price and the wage. And so what we're going to say is that the price is equal to 2 and that the wage is equal to 2. And that's actually going to mean that this is just going to become y equals 24 minus t, because the p and w are the same, so we can just cancel them out. And now what I want is to use this to get the marginal rate of transformation. So the marginal rate of transformation is the slope of this line, right? And to get the slope of this line, well, I could just kind of look at this and think, well, what's the kind of coefficient in front of the t, in front of the sort of the x-axis quantity? Or another thing I can do is differentiate. So to find the slope, I can do dy by dt, and that's going to give me -1. And so the marginal rate of transformation is going to be equal to, so like the modulus, just the magnitude of this. So it's just going to be equal to 1. So I now know what the marginal rate of transformation is, and I know what the marginal rate of substitution is, and I know that the allocations will be optimized where those two things are equal to each other. So where 3y over 2t is equal to 1. So I know that we're going to have an optimal allocation when 3y is equal to 2t. And so where y is equal to 2t over 3. Okay, so we might think, well, is this going to be helpful for us? It is, because we now have one relationship between y and t that has to hold when utility is maximized, and we have a second relationship that has to hold when utility is maximized, because we have to be somewhere along our budget constraint. So what we can do now, and I'm just going to erase a bit of the working out that I've done before, is we can use these two equations to then actually like solve for y and for t, right? Okay, so substituting this into here, I know that 2t over 3 has got to be equal to 24 minus t. And that implies that 2t has got to be equal to, so 3 times 24 is 72, I believe, minus 3t. So therefore, 5t has got to be equal to 72. And then t is equal to 14.4. And what I could do is substitute that value of t back into either one of these equations. If I do, I will get that y, probably easier to do this one, y is equal to 9.6. So what I've now found is the allocation of free time and consumption that will maximize this person's utility. That if they choose 14.4 hours of free time and 9.6 units of consumption, then that will mean that they are at this particular point, which is going to give them they're going to be on their highest indifference curve, their highest level of utility. So that's the other way that we can figure out that optimal allocation. Okay, so that kind of sums up the vast majority of what Unit 3 is about. How do we find the maximum level of utility for a person? But there is one more big idea, which is the income effect and the substitution effect. And I'm just going to take a quick little pause and then I'll talk about that. Okay, so let's finish up by talking about this idea of the income effect and the substitution effect. So these things are relevant when we want to think about something changing that could affect the decision of a person, right? So we're still thinking about the same sort of model here where we've got consumption and free time. And so the red line here represents the sort of initial kind of feasible frontier, the initial budget constraint, where these are all the possible combinations of consumption and free time the person could choose. And we can see that based on the graphical idea, this person would choose 18 hours of free time, I don't know, roughly $100 of consumption, because that would get them to the highest possible indifference curve they could be on, which is this one, IC2. So what we're now going to think about is, well, what happens if something changes? And in this case, the thing we're thinking that is going to change is the wage that the worker could receive. And what's going to change is that the slope of the budget constraint is now different. It's now steeper. And this is down to the wage, because if we think about before, if this person had 16 hours of free time, they could afford, I don't know, $130 of consumption. But now, if they choose 16 hours of free time, meaning they work the exact same amount, they can now afford a much higher level of consumption, which means, well, either the price has gone down, the price of consumption has gone down, or their wage has gone up. So we're going to think about it as the wage having gone up. So with this new budget constraint, with a steeper slope, this person can now get themselves onto a higher indifference curve, right? Because using the same sort of analysis as we looked at before, they're going to choose a point on this new budget constraint, on this new feasible frontier, which will be a tangent to the highest possible indifference curve. And so they end up choosing a combination D. And what's interesting here is if we compare A and D, this person is actually, they're having a smaller number of hours of free time. Let me just pause for 1 second. Sorry about that. Quick emergency stop. So where was I? So I was saying, now that the wage has gone up, the person has now chosen a different level of free time, right? So before, when they had this budget constraint here, this lower red line, they were choosing 18 hours of free time. And interestingly, now that the wage has gone up, they're actually choosing a lower level of free time, right? Actually, what looks, I don't know if it's 17 or but certainly lower than 18, okay? So what we might be interested in is this change from 18 hours to say this lower amount. How much of that is down to the fact that now they kind of feel wealthier? and how much is down to the fact that now working can earn them more money. And those two things are what we refer to as the income effect and the substitution effect. So the income effect is us trying to think about if we didn't change the opportunity cost, i.e., there was no change in wage, okay, there's no change in sort of the relative price of wage and consumption. If we just gave them the extra money to get to the higher indifference curve, then how much free time would they choose compared to before? And the substitution effect is what is the impact of that change in opportunity cost, right? So they have this higher level of income, but now kind of not working is more costly because the wage is higher. The substitution effect tells us like what's the impact of this higher opportunity cost. So how do we kind of disentangle the two? Well, we can kind of think about it graphically. So what I'm going to try and do is actually start off by drawing a red line exactly the same as this one. Okay. So to get the income effect, what we want to do is think there's no change to the opportunity cost, meaning no change to wage, no change to prices, but all we want to do is figure out what would this person do if we gave them enough income to get to the higher utility level. So what we do is take the current feasible frontier, the current budget constraint, and we just think, all right, if we shift this up so that we get to the new, oh, I had it perfect, and then it went off. So that we get to the new indifference curve, right? Where would we be? What would the person choose? And you can actually see if the opportunity cost, if the slope of this hadn't changed, if the marginal rate of transformation hadn't changed, then this person would actually choose this point right here, right? They would have gone from 18 to somewhere over here, right? That this feeling of being wealthier now that the wage is higher would have encouraged them to actually choose more hours of free time, right? So this gap here between A and what I'll call B, that change in hours of free time, that's the income effect. And then we know that in reality, they actually ended up at D, right? They actually decided to have less free time. And that means that this gap between B and D, that right there, that represents the size of the substitution effect, right? It's telling us that actually this like change in opportunity cost has made them want to reduce their free time because now the wage is higher. The opportunity cost of free time is higher because working can earn them more money. So this gap between A and B, so like where they were at 18 hours to where they would be if like the amount of free time they would choose if you'd just given them the extra money with no change in opportunity cost, that gap there represents the income effect. And then the change from where they would be to where they actually end up, that represents the substitution effect. And so the overall effect moving from A to D is just the combination of those two things. It's the income effect, which is actually positive here, plus the substitution effect, we can see is negative. It reduces the amount of free time. And this is how we can actually figure it out. So we think no change in opportunity cost, keep the slope of the budget constraint the same, and we just give them enough income and enough extra money to get to the higher indifference curve and see what they would choose. And they choose to be at point B. But we know they actually move to point D. So the change in opportunity cost is actually making them choose less free time in the end. And so that's how graphically we can show the income and the substitution effect. Okay, so those are the big ideas in Unit 3. How do people optimize their utility? And then how can we kind of interpret people's changes of decision in terms of the income effect and the substitution effect when some factor that affects their decision changes, like the wage, for example. All right, I'll finish up there.